So, section 2.2, sum, difference, doesn't matter. Really, a difference is just adding a negative number to something. But they're basically the same rule, sum or difference rule or tool. So here, if I want the derivative of f of x plus g of x with respect to x, it is exactly what I would hope it would be. It is the derivative of f of x with respect to x plus the derivative of g of x with respect to x. Okay, and again, I could use f prime, or and f prime is what we'd call the Newton notation, and the fraction looking thing is the Leibniz notation. Both are nice, and so yeah, it's exactly what we would hope would be the case. So that's great. And similarly, the derivative of a difference is just the difference of the derivatives. Again, exactly what we would hope. Well, I don't know, maybe we would hope it's just 0 or something, but there you go. There's the rule. And so again, you know, how does that help me? Well, you know, if I have f of x equals 3x squared minus 5x, and I would like that derivative, so f prime of x, well, what I do is I take the derivative of 3x squared, and I subtract the derivative of 5x. But now those, I use my rules. That is 3 times the derivative of x squared with respect to x minus 5 times the derivative of x with respect to x. And both of those are power rules. And one nice thing about this notation is, what does dx over dx look like it ought to be? It seems like it ought to be 1. And it is, all right? But here, so we have 3 times 2x, and then minus 5 times 1. And so we get 6x minus 5. So that's using our sum or difference, and also our constant multiple rule. And so there you go. You know, this is what we do, is if we have and I can have as many of these as I want. All right, so g of x is equal to 2 over x plus 5 times the square root of x and minus 8 times x to the well, let's go with like 3.2. Why not? All right. So here again, well, this is equal to 2x to the negative 1 plus 5x to the 1/2 minus 8x to the 3.2. And so now when I find g prime of x, the derivative, again, now, you know, you can, I'm taking the time right now to go through all of this, right? So first I see sums and differences, so that's the derivative of 2x to the negative 1 with respect to x, plus the derivative of 5x to the 1/2 with respect to x, minus the derivative of 8x to the 3.2 with respect to x. And so then that's equal to 2 times the derivative of x to the negative 1 with respect to x, plus 5 times the derivative of x to the 1/2 with respect to x, minus 8 times x to the derivative of x to the 3.2 with respect to x. And so finally I get my, I'll bring the negative 1 down, right? So that's 2 times negative x to the, and subtract 1 to the negative 2, plus 5 times 1/2 x to the negative 1/2 when I subtract 1 up there, and then minus 8 times 3.2x, and subtracting 1 from that I get 2.2. And so finally, putting that all together, I get minus 2x to the negative 2 plus 5/2 x to the negative 1/2, and then whatever the heck that is, minus 24 plus 1.6, so 25.6 x to the 2.2. And there we go. And that is the sum and difference rules. Again, let's take a look at where that could come from. So suppose I want to take the derivative of f of x plus g of x with respect to x. Then what I need to do is take the limit as x goes to h of that thing at x plus h. So that would be f of x plus h plus g of x plus h. Then minus, now this whole thing, f of x plus g of x, and then divided by h. Limit as x goes to h, sorry, h goes to 0. So this is the limit as h goes to 0. Now all I do is rearrange terms, so I have f of x plus h minus f of x plus g of x plus h minus g of x, all divided by h. Now, once I've rearranged terms, I can split up my fraction here into the sum of two fractions. So this is the limit as h goes to 0 of f of x plus h minus f of x over h plus g of x plus h minus g of x all over h. So I can do that, but now I have the limit of a sum, but that's the sum of the limits, so this is the limit as h goes to 0 of f of x plus h minus f of x over h plus the limit as h goes to 0 of g of x plus h minus g of x over h. So I've got those two separate limits, but we know that this first limit is f prime of x, or df of x dx, plus g prime of x, or dg of x dx. And so there we have it, that that derivative of the sum can be written as the sum of the derivatives. And with the minus, same thing. I'm just going to show you, so what happens if it's different? Oh, well, see, that would be a minus, and that would be a minus. What happens then? Well, when I rearrange, you still get f of x plus h minus f of x. But here, instead of plus g of x, this would have been a minus here, and that one would have been a plus. Oh, well, factor the negative out, and you would have that with the two fractions, and then the minus just follows. Okay, and so we get the minus. So there we go. There's our sum and difference rules, and so we're building up lots and lots of tools here.